Okay, good evening dear students. Today we are discussing properties of alcohol. Before that, what are the preparations of alcohol? Alcohols are prepared from alkane by oxidation reaction. Here reagent is potassium permanganate. Second one, alcohol prepared from alkene. Here two reaction. One is by catalytic acid hydrolysis reaction. Second one, poration followed by oxidation. Next, alcohol prepared from alkyl halide. Here two types reaction. One is with aqueous KOH or NaOH. Second one with moist silver oxide. Another model, alcohol prepared from ethers. Here two types. One is by hydrolysis reaction. Second one is with hydrogen iodide. That is cold dilute hydrogen iodide. Next, alcohol prepared from carbonyl compound. Here three types. One is catalytic hydrogenation reaction. Reagents are one is nickel or palladium or platinum dioxide. Second type reaction is reduction with lithium aluminum hydride. Third one is reduction with sodium borohydride. Next, alcohol prepared from carboxylic acid. Here only one reaction, that is reduction. Reagent is lithium aluminum hydride. Next, alcohol prepared from esters. Two type reaction. One is with aqueous KOH. Second one is with lithium aluminum hydride. Finally, alcohol prepared from aliphatic primaramine. Here with nitrous acid. These are the preparations of alcohol. Now we are taking properties of alcohol. What are the properties of alcohol? Properties of alcohols are two types. One is physical property, second one chemical properties. Now we are taking physical properties. What are the physical properties of alcohol? One is physical state, second one boiling point, third one solubility. As per your NCERT, we are discussing only three. One is physical state, second one boiling point, third one solubility. Now one by one. Properties of alcohol. First one is physical properties. Physical properties. In the physical properties, first physical state. Physical state. Here first one, lower alcohols are colorless liquids. Colorless liquids. You take one example, methanol or ethanol. Ethanol, another name ethyl alcohol. Ethyl alcohol is colorless. Methanol also colorless. So first point, lower alcohols are colorless liquid. If we take higher alcohol, you know the higher alcohol greater than 11 carbon atom alcohols. C1 to C11 carbon of alcohols are lower alcohol. They are colorless liquids. Higher alcohols are colorless, odorless, waxy solids. Waxy. waxy solids. Okay, this is the physical state. Now I am taking very important boiling point. First one is the boiling point of alcohol is greater than ether and hydrocarbon. Why? Alcohols having intermolecular hydrogen bond. Means there was able to formation of intermolecular hydrogen bond. So boiling point of first point, boiling point of alcohol greater than ether and hydrocarbon of comparable masses. Reason, due to the formation of intermolecular hydrogen bond. Intermolecular hydrogen bond. If you have any doubt, observe the structure R O H. Due to highest electronegativity on oxygen, it creates negative pole. Hydrogen automatically creates positive. Another alcohol, oxygen, hydrogen. Negative pole on oxygen, positive pole on hydrogen. Here, intermolecular hydrogen bond formed between different polar alcohol molecules. Due to the formation of intermolecular hydrogen bonding between two alcohols, it has highest boiling point. Example, diether. Okay, okay. Example, diethyl. Example, first one, ethyl alcohol. Ethyl alcohol, 2 carbon. Here its molecular mass 46. Molecular mass or molecular weight. Its molecular weight 46. Dimethyl ether. Its molecular mass 46. Propane. Propane formula C3H8. Carbon atomic weight 12 into 3 36. Hydrogen atomic weight 1 into 8. It is equal to 44. 46, 46, 44 means comparable masses. In the comparable masses of alcohol, ether, and alkane, that is hydrocarbon, alcohol having highest boiling point than ether, than hydrocarbon. Why alcohol having highest boiling point? It was able to the formation of intermolecular hydrogen bond. Okay, this is first model. Second one, among alcohols, as the size of alkyl group increases, as the size of alkyl group as size of alkyl group increases, boiling point also increases. It means size of alkyl group directly proportional to boiling. Why, sir? What happened? Here, as size of alkyl group increases in alcohol, surface area increases. Due to this, van der Waals forces are increased. Van der Waals forces directly proportional to boiling. Hence, the boiling point of alcohol increases as the size of alkyl group increases. You take one example. Ethanol, 2 carbon. Ethanol, 3 carbon. Propanol, 4 carbon. Butanol, 1, 2, 3, 4. Butanol, last one. 1, 1, 2, 3, 4, 5. Ethanol, propanol, butanol, pentanol. Observe size of alkyl group. This is the size of alkyl group. Here, size of alkyl group. Here, another size of alkyl group. Finally, this is the size of alkyl. Size of the alkyl group gradually increases. So surface area, suppose here 2 centimeter, here 3 centimeter, here 5, here 8. Surface area increases. Hence, their van der Waals forces are increases. Therefore, their boiling point increases. This is the order of boiling point of various types of alcohol. Okay. Next, continuation. Among isomeric alcohols, among isomeric alcohol, isomeric means primary, secondary, tertiary. Among isomeric alcohols, the order of boiling point of alcohol is the order of boiling point is primary alcohol greater than secondary alcohol greater than tertiary alcohol. Why? Why primary alcohol having highest boiling point then compared to secondary, then compared to tertiary? Here only one reason. In primary, surface area of the alkyl group increases. If number of branches increases, surface area of the alkyl group decreases. Surface area decreases. Hence their boiling point decreases because of decreases of van der Waals forces. If you have any doubt, we take one example. Butanol example. But 1, 2, 3, 4 OH. Butanol, observe CH2 here. To primary, CH2OH indicate primary. Secondary, OH. Here CH. 1, 2, 3, 4. Here 1, 2, 3, 4. OH group bonded carbon which is bonded with two other carbon, it is secondary. Means branches increases. In tertiary, OH. Here C. Round up indicate primary alcohol, secondary alcohol, tertiary alcohol. In primary, observe the surface area. This is the surface area. Here surface area. Here this is the surface area. If number of branches are increases, surface area decreases. Therefore, van der Waals forces are decreases. Hence, their boiling point decreases. So, what is the order? Primary greater than, secondary greater than, tertiary. This is the boiling point concept. Now, we are taking third model, that is solubility. Solubility. Okay. If we take your favorite movie, Bahubali 1 or 2, or any movie, your favorite hero or heroine or villain, every person taking alcohol. How? A little amount of alcohol taken in glass, and then excess of water added into the same glass. What happened here? Alcohol is dissolved in water. What is the reason? Due to the formation of intermolecular hydrogen bond with water. So what is the first bond? Lower alcohols are soluble in water due to the formation of intermolecular hydrogen bond. So first bond, lower alcohols are soluble in water due to the formation of intermolecular hydrogen bond. To take example, first representation, solubility. Lower alcohols are soluble in water. Reason, due to the formation of intermolecular hydrogen bond. Intermolecular hydrogen bond. If you have any doubt, you take structure ROH. Oxygen is highest electronegativity element, so it creates negative pole on hydrogen first. Water OH. Positive pole, negative pole, positive. Actually, here two negative poles. Another alcohol ROH. Negative pole, positive. Here observe, between hydrogen atom and high electronegativity atom, it was able to formation of intermolecular hydrogen bond. Here also it was able to formation of intermolecular hydrogen bond. Due to the formation of intermolecular hydrogen bond with water, observe, with water, this is water. Alcohols was able to the formation of intermolecular hydrogen bond with water. They are soluble in water. Okay, this is first model. Second one, among the alcohol, the size of the alkyl group is inversely proportional to solubility. Inversely proportional to solubility. Why, sir? order. Why? What is the reason? Here, as the size of alkyl group increases, hydrophobic part increases. Hydro means water, phobic heating. Here hydrophobic part is less. Here hydrophobic part increases. R means alkyl group. Alkyl group is carbon-carbon bonded. Carbon-carbon bonded is covalent bond, one type of covalent bond. These covalent bonds are does not break in water. Okay, so here as size of alkyl group increases, the solubility of alcohol decreases because of increases of hydrophobic part of alkyl group. Hydrophobic part of alkyl groups insoluble in water. This is the concept, expected model. The third one, among the isomeric alcohol, as number of branches increases, like this model. Hydrophobic part, size of the hydrophobic part decrease. So automatically solubility increase. So order, solubility order. Same structures, order. Okay, note down fastly. Don't represent these lines. Read structures only. Here also. Okay. Now we are taking chemical properties. Chemical properties. Here, alcohols can act as alcohol can act as first one nucleophile, second one electrophile. Alcohol act as nucleophile and electrophile. So what is the difference between electrophile and nucleophile? First we are taking nucleophile. Nucleophiles are electron rich species. Electrophiles are electron deficient species. For your easy identification, World Bank or any bank, money rich species like electron rich species, so they are considered as nucleophile. Generally, every human being is money deficient persons like electron deficient. That's why they are considered as electrophile. Simply says electron rich species are called nucleophile. electron deficient species are called electrophile. But alcohol act as nucleophile as well as nucleophile, electrophile. Now we are taking alcohol as nucleophile. First one, alcohol as nucleophile. Nucleophile. If alcohol as nucleophile, it involved in the bond between oxygen and hydrogen. Oxygen and hydrogen dissociate. I repeat, if alcohol as a nucleophile, the bond between oxygen and hydrogen dissociation. Dissociation. Why? What is the reason? Here in oxygen, two lone pair of electrons are there. Two lone pair of electrons. It is the electron rich species. Okay, what is the mechanism? Observe the mechanism. Alcohol, it is nucleophile, react with electrophile. Generally, electrophiles are positively charged species. Due to the lone pair of electron on oxygen, it is ready to donate to the carbon. Gives rise to R, O, H, C bond. Okay. Here, when electron pair donate to the carbon, how many remaining lone pair? Only one with the positive charge. Why positive charge? Here, oxygen was able to formation of 3 bonds. If oxygen carrying 3 bonds with the positive charge. Okay. Here, next one, important. Due to highest electronegativity on oxygen, these sigma bond electrons shift toward the oxygen. It means it creates negative charge, it creates positive charge. It means which is breaking? OH bond breaking. When OH bond is breaking, gives H plus. What is the remaining? R, O, double bond, sorry, two lone pair with the carbon. Or sometimes it was able to the formation of double bond. Okay. So here, if alcohol acts as nucleophile, it is involved in breaking of OH bond. Okay. If it is involved in the OH bond breaking, it liberates H plus. According to Branchett-Lowry theory, if the substance gives proton or proton donor is called acid. So here, in this reaction, alcohols act as acids. Okay, example, acidic nature of alcohols example. First, action of alkali metal. Here, first one, action of alkali metal. Alkali metal generally sodium. Okay, general reaction. Alcohol react with sodium metal in gives rise to what is the product? Here, it is involved in breaking a bond between oxygen and hydrogen. It means hydrogen displaced by sodium. Gives what is the product? RONA, sodium alkoxide, with liberation of hydrogen. Here how many hydrogen? One. So you take off. Here question arised between alcohol and hydrogen gas or sodium with hydrogen gas. Mole-mole relation or mole-volume relation. Here weight-weight relation or mole-volume relation. In our material, exercise 1, exercise 1. In the exercise 1, 27th question. 27. What is the question? 23 grams of sodium will react with methanol to give. 27th question. Methanol react with sodium gives rise to what is the product? Here OH hydrogen replaced by sodium. So CH3ONA plus of H. Balanced. I think it is balanced. Okay, here how many grams? 23 grams. In the question, 23 grams of sodium will react with methanol to give how many moles of hydrogen? 1/2 mole of hydrogen. This is the answer. Our material question, 23 grams of sodium react with methanol to give a mole of hydrogen. This is one model. Second model, bit number 12. Second model, bit number 12. Observe this bit number 12. C2H5OH react with sodium metal gives C2H5ONA plus of H2. I think it is balanced. Okay. Here, how many moles of methanol? How many moles? 1 mole. Its molecular weight? Its molecular weight 32. Carbon 12, oxygen 16, hydrogen 4. So 20 plus 12, 32. In the question, first of read the question. When equal weights of methyl alcohol and ethyl alcohol react with excess of sodium metal, the volume of hydrogen liberated is more in the case of. Here keep in our mind equal weight of methyl alcohol and ethyl alcohol. Weight is same, but which is different? Molecular weight. Okay, you take. Here how many mole? 1 mole. 1 mole of methanol gives how many moles of hydrogen gas? Half mole. Or if you take volume, 11.2 liters of hydrogen. In the question, equal weight of methanol, weight equal, suppose W, we don't know weight, so W by 32 grams of weight by gram molecular weight indicate mole. W by 32 moles of methanol gives how much volume of hydrogen? Cross multiplication. W by 32 into 11.2 divided by 1. W by 32 into 11.2 by 1. That are equal to 11.2 W by 32 liters. Okay. In case of ethanol, there also same 1 mole gives 11.2 liters of hydrogen. Equal weight W by ethanol molecular weight 46 mole gives how much volume of hydrogen gas? Here cross multiplication. W by 46 into 11.2 by 1 that are equal to 11.2 by W by 46. Here 11.2 W, 11.2 W. Okay, same. Here denominator value less, here denominator is more. If denominator value increases, the volume decrease. So methanol liberate highest amount of highest volume of hydrogen than compared to ethanol. Okay, note down fastly. Okay, first read the question. Exercise 1, bit number 12. Equal weight of methyl alcohol and ethyl alcohol react with sodium metal. The volume of hydrogen liberated is more in the case of methanol and ethanol react with sodium metal, liberates of mole of hydrogen. Means 11.2 liters of hydrogen. Okay. 1 mole of methanol gives 11.2 liters of hydrogen. 1 mole of ethanol gives 11.2 liters of hydrogen. If we take only same mole, same volume of hydrogen liberated 1:1 ratio. But in the question, equal weight is same, but molecular weight different. So what? Equal weight means W by 32 gram. Moles of ethanol liberate how much volume of hydrogen gas? 11.2 W by 32 liter. In case of ethanol, W by 46. What ethyl alcohol marker weight 46. W by 46 mole gives how much volume of hydrogen gas? 11.2 W by 46. Here denominator value more. So volume of hydrogen less. Here denominator value is less. So volume of hydrogen is more. So here answer methanol liberate more volume of hydrogen gas. Okay. Next, I told you this reaction indicates alcohols are acidic. Alcohols are second point, need point. Alcohols are acidic. This reaction indicates that alcohols are acidic. Why they are acidic? According to Brunsteit-Lowry theory, what is acid? The substance gives H plus ion. H plus ion converted into H2. Here H plus ion converted into H2. Okay. Here, due to liberation of H plus. Okay. Second point, alcohols are less acidic. Important, less acidic than water. Reason. What is the reason here? First reason, alcohol dissociation constant symbol Ka. Alcohol dissociation constant here equal to 10 power minus 16 to 10 power minus 18. Alcohol dissociation, water dissociation constant Kw. W means water. Water dissociation constant equal to 10 power minus 40. Here Ka value minus 16, 10 power minus 16, here 10 power minus 14. Which is more? Water Kw, dissociation constant is more. Within the bracket, K directly proportional to acidic. Dissociation constant directly proportional to acidic. Second one, observe this second one. Alcohol, ROH, water, HOA. R means alkyl group has plus I effect. Here plus I effect is more. Plus I is more. That's why index to plus I effect inversely proportional to acidic. Here plus I less. So plus I effect inversely proportional to acidic. Third one given in the material. Third one point of view, listen. For your senior students, practice point of view, central government created one app that is National Testing Abbas. In National Testing Abbas, 15 questions given from alcohol concept. Okay, one of the question is electron withdrawing group directly proportional to acidic. Nature of alcohol. One small example, given example. Observe two carbon with aminochlorine 3. These are electron withdrawing groups. Two electron withdrawing group with ethyl alcohol. One electron withdrawing group lost ethyl alcohol. Here number of electron withdrawing groups are increases, so acidic nature increases. So this is the order of acidic nature. Order of acidic nature. This model given in NTA, National Testing Abbas. Okay. Finally, the order of acidic strength of acidic strength of the order of acidic strength of various types of alcohol. Various types of alcohol follow the same order. Follow the same order. What is the order? Primary, first methanol, most acidic, greater than primary alcohol, greater than tertiary alcohol, greater than primary, secondary, tertiary. I think you have wondered why tertiary alcohols having less acidic nature. Then compared to secondary and primary. In tertiary, number of alkyl group increases. Number of alkyl group. Alkyl group are plus I effect group. Plus I effect inversely proportional to acidic nature. Ma Deepika, hello, Deepika, what's your doubt? Hello,
Sir, board is not clear, sir.
sure. అందరికీ ఉందమ్మా.
Yes, sir.
Okay. Okay.
Okay, sir. Okay, sir.
Is it clear? Last point. Acidic nature order. Water more acidic than alcohol. Alcohols are more acidic than ethyne. Ethynes are more acidic than alkene. Alkenes are more acidic than alkene. Do first. Last point in reaction with alkali metal. Here on oxygen, two lone pairs are there. Due to the presence of two lone pair on oxygen, it is accept the protons. Proton acceptor is called Bronsted-Lowry base. Okay. Next, second reaction, that is esterification. Esterification reaction. Esterification reaction. What is esterification reaction? Alcohol react with, here alcohol separation R1 star, oxygen coming from alcohol react with carboxylic acid or COOH. In the presence of acid, that is H plus, gives what is the product? Here, breaking of OH bond. Here, breaking of CO bond gives rise to what is the product? Water. What is the remaining? RCO O R. Here ester is formed. That's why it is known as esterification reaction. So what is fissure esterification reaction? Alcohol react with carboxylic acid in the presence of acid, that is sulfuric acid, gives rise to ester. The formation of ester from alcohol and carboxylic acid is called esterification reaction. Okay, esterification reaction, it is reversible and slow reaction. In our material, one important question, our material, exercise 1, 35 question. 35 question. The bond cleavage during esterification reaction between acetic acid A, B, ethyl alcohol, C2H5OH, this is B given, acetic acid CH3COOH, this is A. In esterification reaction, gives what is the product? Here breaking of OH, here breaking of CO, gives rise to water. What is the remaining? CH3COOC2H. So what is the answer? In A, CO bond breaking, and in B, OH bond breaking. Okay, continuation, need point. The rate of esterification of alcohol is rate of esterification of alcohol is methanol more reactive towards esterification, then after primary alcohol, next to secondary alcohol, next tertiary alcohol. Okay, that's another important general reactions. Ethyl alcohol react with carboxylic acid. Carboxylic acid, best example acetic acid, in the presence of acidic medium. And also it is react with acid derivative. What is the acid derivative? That is acid halide. Acid halide CH3COCl. In the presence of pyridine. Third one, acid derivative is anhydrides CH3CO. Both are added to oxygen. This is example of anhydride in the presence of acidic medium. Gives what are the possible products. Here hydrogen OH group converted into water. What is the remaining? CH3COOC2H5. CH3COOC2H5. Ester is formed. Next, in the second one, here hydrogen, here chlorine, gives rise to HCl. Remaining acid CH3COOC2H5. Next here hydrogen CH3COO group converted into acetic acid plus CH3 COO C2H. Okay. So every reaction is example of esterification reaction. What is esterification? Ester formed from alcohol and carboxylic acid, and their derivative is acid halide or anhydrous. Okay. Next one, with nitric acid. Alcohol, best example ethyl alcohol, react with nitric acid. Nitric acid representation HNO3, actually representation OHNO2 gives rise to what is the product? Here OH bond breaking, hydrogen, here OH group converted into water. What is the remaining? C2H5ONO2. Here oxygen bond between carbon and nitrogen, it is example of inorganic ester. Inorganic ester. Okay, this reaction is also example of OH bond breaking. Okay, OH bond breaking reactions, one is with sodium, second one with carboxylic acid, with acid halides, with acid anhydrides, with nitric acid. Last one is there, that is Grignard reagent. Total 5. I repeat, alcohol act as nucleophile in the OH bond breaking reaction. Which of the following is OH bond breaking reaction? One is with sodium or alkali metal. Second one with carboxylic acid. Third one with acid halides, with acid anhydrides, with nitric acid, with Grignard reagent. Okay, after this one, very important related concept. It is benzene. It is benzoic acid. Benzoic acid. Here OH group. This is indicate orthohydroxybenzoic acid or orthohydroxybenzoic acid. Another name, salicylic acid. Salicylic acid. Okay, react with acetic anhydride. Acetic anhydride, this model. CH3CO, CH3CO react with, bonded with oxygen. In the presence of acid, that is sulfuric acid. Here hydrogen CH3COO group converted into acetic acid. What is the remaining? Urate acid structure. Alternate double bond. COOH. Here oxygen with COCH3 group. CO CH3. CH3 representation. Okay, its name aspirin. Okay, what is the concept of aspirin? Aspirin concept. Listen, very, very, very important. Aspirin. What are the functional group in aspirin? Functional group. COOH, COO. COOH and COO group. Not my data. Previous NEET and MSET, any different type questions. Functional groups in aspirin, carboxylic acid and ester. Okay. Its name acetyl CH3CO. Name aspirin name acetyl salicylic acid. Acetyl salicylic acid. Okay. Here in aspirin, number of sigma bonds. How many sigma bonds? Up to here, 12 sigma. 13, 14, 15, 16, 17, 18, 19, 20. Oh, sorry, 1 minute sing. Here 14, 15, 16, 17, 18, 19, 20, 21. So total sigma bond 21. And pi bond. In benzene ring 3, here 1, total 5. Next. In the chemistry in everyday life topic, it is used as analgesic. Second one, anti-inflammatory. Third one, antipyretic. It prevent blood coagulation. That's why it is used for heart attack patients. This is complete information about the aspirin. Okay.